Hey guys, let's discuss new Apple interview loop round 3, which is called coding round 2. Okay, so here we will be discussing. The question is given to you is design a median from data stream. So you are getting a data stream, okay, and means continuous data, continuous number from that stream. You don't know the length of the data, okay. So continuous stream, and you need to find the median. How you will find it? Okay, so let's see. Here we will be seeing answer based on 3 roles: software engineer, senior software engineer, and principal architect. Okay, so again, expectation differ by level. So let's see what software engineer expected to answer. So see, implement an efficient median from a stream solution using heap. So here you will be using heaps, okay, or B tree also you can use. We will see heap. Now explain complexity and write comprehensive test cases. What senior software engineer will say: extend the solution to millions of records with memory optimization, concurrency, and fault tolerance. So software engineer was concentrated on the implementation part, and senior software engineer was concentrated on large scale implementation. Okay, so like the system should handle the millions of users. Now architect will say design a distributed streaming system supporting windowed, median, horizontal scaling, data partitioning, and production monitoring. What is windowed median? So see, let's say you windowed median means finding the median of a moving window of fixed size in a data stream. So you have a window, okay, of fixed size, but it is moving. So you will find median from each window. Okay, so now let's see you have a number like 13579. Okay, this is the array or data stream you can say. So and window size is 3. Okay, so first time this one will be the window part, okay, second time this one, and third time this one, right? So 135, what is the median? 3. 357, 5 is the median. 579, 7 is the median. So what is the answer? 357. Okay, so this is how. Now software engineer will answer that I would maintain 2 heap, okay, maximum heap for the lower half of the numbers, and minimum heap for the upper half. I would keep the heap balanced so that their sizes differ by at most 1. Okay, and this allows us to insert number in order log n time and retrieve the median in order 1. So very simple. Okay, what you will do, you will maintain 2 heap. One is min heap, okay, mean heap, and then another is max heap. Okay, let's say you have a number this 1379. Okay, you have this 1379. So first 1 will come, so it will go to max heap. Okay, second time 3 will come, so it will go to again max heap. Okay, but then you know that the difference between these 2 heap is always at most 1. So right now it has a 2 element, it has 0 element, so 2 minus 0 is 0. So you will rebalance that. Okay, so you will put this 3 here in this mean heap, right? Now next 5 will come, so 5 will go to max heap. Okay, so 5 will come here, then 7 will come, so 7 will come here. Again the difference 3 minus 1 is 2. So what you will do, you will put 1 element there, so 1 will come here. Okay, it will go from here. Now next time 9 will come, so 9 will come here. Again 3 and 2, which is 1, which is correct. Okay, so now what is the median? Okay, so either the top element is this one, 3 here, okay, and what is the top element here? It is 9, right? Not 9 actually, this is the you will see 3, and here it is 5. Okay, you will check the this one, the last one. So now see how many elements you have, like odd number of element or even number of element. Right now you have a odd number of element. Okay, so for odd whatever is the maximum, just return that one. So here you have a 3 elements, so return this 5. So 5 is your answer. If it is even, like 10 is here, right? In that case 10 will be here, and then when you balance it, this 5 will go here, so 5 will come here. Now you have 7 and 5, so you will figure out the median 7 by 5 divided by 2, so like 6 or something. Okay, something like that. So this is how you will figure out. Very simple, just to maintain 2 heap. using priority queue. Okay, so approach will be maximum heap and minimum heap you will maintain. Store the lower half of the number and store the upper half of the number. Okay, now keep the two heap balanced. Balanced means always the difference should be 1. The difference between their size should never exceed 1. Okay, if the total number of elements is odd, the root of the larger heap is the median, and if the total number is even, the median is the average of both the heap root. Okay, we have seen that. So complexity, insertion order log n, median order 1, space complexity order n. Okay, now test cases. What all test cases you will be testing here? So first of all, empty stream. Okay, second is single element, then 2 element, then odd number of element, even number of element. After that, duplicate value, negative number, already sorted input, reverse sorted input, and very large values. So Java code, if you see, first you maintain, see, this is your MedianFinder class. Okay, and then you will maintain two heap, lower half, this one. Okay, let's say max heap, and this is the upper half, so this is the mean heap. So 2 priority queue you have created, and then this is your MedianFinder. So MedianFinder, what it will do, first of all, it will put all the value in reverse order. Okay, into the max heap, so you can put there also, and min heap will be empty initially. Now add number. Okay, so you will get the number, and you will add it to appropriate heap. You will check which heap this number should go, and you will add there. Okay, so like for example, add the appropriate heap. If the max heap dot is empty, if max heap is empty and number is less than equal to max heap ka pick, means the first element. Okay, so put that, offer that in a max heap, otherwise in min heap. Okay, second is balance the heap. Okay, so you need to check this one also. So max heap ki size is greater than minimum heap size plus 1, then you will, what you will do, take element from max and then put it into the mean, otherwise do vice versa. Then find median. How you will find the median? I have told you 2 conditions: odd number of elements and even number of elements. If it is odd number of elements, then you will check whose size is greater, and you just return it's a peak element. Okay, similarly for this one. And then if it is even, so just take the 2 element from the heap. Okay, first 2 element and divide it by 2 and return that. Okay, now let's talk about few follow-up questions. So 5 follow-up questions we will be seeing here. Okay, the first one is, how would you handle millions of records? So software engineer will say that continue using the two-heap approach, avoid sorting the complete data set after every insertion, and store only the state required to calculate the median. Okay, the same thing. Senior software engineer will say, for millions of record, I would focus on streaming ingestion. Okay, so first of all, streaming is required. Then memory efficient data structure, avoiding unnecessary object creation, batching where appropriate, state management, back pressure, and monitoring memory utilization, and avoiding a single process becoming bottleneck. So all that common thing he's talking here. Okay, which you can use everywhere in the system, for any system, right? So if the exact median is required, we need to preserve enough information to calculate it accurately. Now what architect will say, a very large scale, I would first clarify whether the business required the exact median, okay, or the partial one. So if approximate result are acceptable, we can use manageable quantile algorithms such as KLL Sketch and T-digest. We don't need to go into the detail of these algorithms. Okay, this allow individual worker to maintain compact summaries that can be later be merged. So you will have a multiple workers, they will be working on they will keep the local copy, and later we will merge that local copy. So that is how you will be handling millions of users, millions of streaming data. So the key architecture question is, do we need exact median or appropriate median within an acceptable error range sufficient? Okay, so this is what you will ask. Now follow-up question 2 is, how do you handle concurrent writes? So multiple write are there. Let's say software engineer will say that protect heap operation from concurrent modification, where the concurrent modification will happen on heap only. Okay, you have only 2 heap. Now use synchronization where required. Okay, and then ensure insertion and heap rebalancing happen automatically, and prevent 2 threads from corrupting heap state. Now what senior software engineer will say, so he will be saying Okay, he's talking about the locking system. Okay, so a global lock around the entire data structure could become the bottleneck. Okay, possible approaches: single write model. You can go with single write model, producer consumer architecture, thread safe queue, or batching update, lock partitioning, partition processing. Okay, so we have already discussed this in detail in the earlier video, so I'll not be discussing it. Now the objective is to allow multiple producer without allowing inconsistent heap state. Now what architect will say: move concurrency management from a single in-memory object to distributed stream processing architecture. Architect always talk about distributed system. Okay, right now if it is a single in-memory, okay, then just distribute it for the multiple on the multiple servers. This avoid having every producer directly modify one global sharded object heap. Okay, follow-up question 3 is: how would you make the system fault tolerant? So software engineer will say: validate incoming data, handle invalid input gracefully, and then prevent heap corruption, handle exception during processing, and then ensure partially processed records don't leave the data structure inconsistent. Senior software engineer will say that he will introduce periodic checkpoints. Okay, time to time they will check the data, and then persistent state event replay. Okay, you can replay the event also. Consumer offset. So let's say consumer is reading, okay, from your queue, and suddenly something happened, consumer shut down, then next one will come, or that one on the restarted, so it should read from the place where it has left. Okay, so we will have the offset there. Now duplicate event handling, idempotent processing and recovery after process failure. So now if a worker crashes, it should be able to reconstruct its state without losing data. Architect will say the system should support the first one is durable event storage. Okay, then check pointing, state replication, consumer offset, replay, automatic worker recovery, and then idempotent processing. Okay, the event stream becomes the source from which processing state can be reconstructed. The follow-up question 4 is: how would you partition the data? If you have a lots of data, how will you partition that? So use partition key. Okay, keep the workload reasonably balanced. So partition key you will be using. Senior software engineer will say that consider even distribution across the servers, ordering requirement, number of partition hotkeys, and then consumer capacity and rebalancing. Avoid sending the majority of traffic to a single partition. If majority of traffic is going to single partition, that is called hot partitioning. So you have to further divide that partition again. So architecture, if you see, the partitioning strategy should match the aggregation requirement. Okay, so see, if it is per user, then user ID will be your partition key. If it is per region, then region will be your partition key. Per device, so device ID. Global median, so distributed local summaries, and then global aggregation. I told you, right? Each worker will have its own local copy, and then later we will be merging that. Okay. The architect should explicitly explain the trade-off between local aggregation, global aggregation, partition skew, and network cost. Okay. Now follow-up question 7 is saying: how would you handle a hot partition? So software engineer will say: identify the overloaded partition first, then check whether the partition key is generated excessive traffic. Yes, that is also true in case of hot partition, right? Then redistribute the workload where possible. So he will redistribute it among multiple servers. Software engineer will say possible techniques is better partitioning, increase partition count, key salting, dynamic rebalancing, load monitoring, and separate high volume customer or devices. Okay, so now what architect will say: I would monitor partition level traffic rather than only looking at the overall throughput. Track records per partition, processing latency per partition, state size, consumer lag, and CPU utilization. So a system cannot truly scale horizontally if one partition remains bottleneck. That is true, right? Architecture, so whatever I am telling you, that is in the architecture. Okay, so let's say this is the producer is your multiple machines like mobile app or web client. Okay, and then it will go request will go to message broker, either Kafka, RabbitMQ, Pulsar, it will have a multiple partition, and that partition, so multiple worker will work with that partition, okay, consume the data, and that data will go to local state partition, okay. From there it will aggregate, and then you will find the median, and then on monitoring layer will monitor all these processes like alert, logs, dashboard, or metrics. So that's it. Thank you.